That was the effect of a 3-inch mortar firing high explosive. Now let us see how this fire effect was produced. In the scenes which follow, a mortar detachment has been placed under the orders of a company commander for an attack. The company commander orders the mortar detachment to neutralize a target with HE. The detachment commander makes a quick reconnaissance. Signals up his detachment, which he has kept under cover as near as possible to company headquarters. Arranges for laying the mortar in the right direction. And sends the orderly to the observation post. The mortar detachment advances, carrying its mortar and ammunition. Notice that they are in extended order. They are ordered into action. And open fire. Note the spikes sinking into the ground. The commander observes the fall of the bomb, orders the necessary corrections, and another bomb is fired. Watch the destructive effect of the HE bombs. The mortar can also be used to produce a smoke screen. The smoke is produced by white phosphorus. Notice the tendency of this chemical to pillar as each bomb explodes. Now consider the weapon and its ammunition in detail. It consists of the component parts which you see here. The barrel, sight case, base plate, spare parts bag, breech piece spanner, bipod, and ammunition carrier. The barrel consists of the breech piece, which unscrews and which contains the striker stud. It is the striker stud which fires the bomb. The recoil spring, buffer ring, the muzzle, and the muzzle cover to prevent rain getting down the barrel. Note how the bipod legs are kept closed for transit and how they are opened and clamped by the operating pins. This is the clamping handle, by which the clamping plate can be set in different positions. Here is an example of how, by the use of this device, the mortar may be mounted upright, though the bipod legs are on uneven ground. Notice the spikes, the lifting loops, and the socket with lugs on either side. First, the base plate is placed in position. Then the breech piece of the barrel is inserted into the base plate socket and turned a quarter of a turn to lock the barrel behind the lug. The muzzle cover is removed. The bipod is placed in position with this handle, the operating handle, to the rear. The barrel is guided into the cradle. The recoil spring is attached to the hooks on the cradle. The muzzle cover is replaced. Watch the action of the elevating gear and operating handle. Over and to the left raises the mortar and thus reduces the range. Over and to the right lowers the mortar and increases the range. If you find this hard to believe, try firing it like this. Note which way the traversing gear works. Handle towards you brings the mortar towards you. Handle away from you, mortar away from you. The sight is now being fitted onto its bracket and locked. So that they can be easily identified, HE bombs are painted with red and green bands below the fuse. Smoke bombs have a red ring and all the rest of the head is painted green. When an HE bomb explodes, it breaks into fragments like these. The safety caps on most types of bombs are removed by unscrewing. For practice purposes, there is the powder-filled bomb with red and yellow rings and the drill bomb, painted black with no markings but with the word drill stamped on it. The tail unit must be kept dry and is therefore provided with a waterproof cover. The tail unit contains the primary cartridge, which you see here, and also contains 6 secondary cartridges. When firing at ranges between 525 and 1500 yards, all the secondaries are left in, and this is known as charge 2. For ranges between 275 and 850, charge 1 is used, and this means removing 3 of the 6 secondaries. Any 3 may be removed. The bombs are carried 3 in each expendable carrier. Carriers containing HE are painted with a yellow band. Those with smoke have a green band. And those with powder filled have a black band. All are sealed with adhesive tape. In taking a correct aim with the mortar sight, the eye should be about 3 inches away from the sight. Either eye may be used, but preferably the right. This is a correct aim. Notice that the top of the pyramid of light, which you see through the sight itself, is in line with the center of the aiming mark, which can also be seen along the V at the top of the sight. The barrel and sight only point in the same direction when the cross-level bubble is central. For instance, when the sight is like this and the bubble like this, they are obviously useless. It is therefore necessary to keep the cross-level bubble central whilst the mortar is being laid. So a number 2 is required to assist in laying. The number 1 must warn the number 2 which way he is going to traverse, so that the number 2 shall know which way to turn his cross-leveling screw. If the aim is above or below the aiming mark, in this case it is below, it may be adjusted by the collimator adjusting screw. Elevation is obtained by first setting the required charge and range on the range scale. Charge 2, marked full on the sight, 900. The correct elevation is put on the mortar by raising or lowering it until the longitudinal bubble is central. Charge 1, marked red on the sight, 450. Number 1 gets a rough idea how much he is off the direction with hand angles, and roughly corrects direction with the traversing handle. Number 2 centralizes the cross-level bubble, whilst number 1 puts on the correct elevation. Accurate direction is now obtained, both numbers working together. The elevation is checked, any final adjustment for direction is made, and the mortar has now been laid. By means of the direction dial and drums, it is possible to lay the mortar any number of degrees to the right or left of the aiming mark. Left, 99 degrees. Which means that the mortar is laid 99 degrees to the left of the aiming mark.